I suggest the instructors to play the game 3 times at least, following this sequence. The first 2 times are news vendor games and the third time is a shortage game. I suggest to play the first news vendor game without telling the students the news vendor model, so the students can try an error. After the first game, you can teach the news vendor model and then ask your students to play the game again, so they can apply the news vendor solution and see the impact. Each game will take about 30 minutes if you use 5 minutes for each round, and there are 6 rounds. In the shortage game, the instructor please sets supply per player to be less than 15. I would suggest either 12.5 or 10, depending on how intensive you want the competition to be. Choose the demand and game parameters as you wish, but be sure to make sell price greater than the cost. Please inform all students of the game parameters, especially the total supply capacity, to create a competitive mindset. I suggest to play the first 3 rounds of the shortage game without revealing the competitive information. So give the students a chance to figure out how competition affects their profit. At the end of the third period, you can have an interactive session where you can ask the students about their game experiences and observations. You can debate on whether the students should tell the truth or inflate the orders. You can also do a small lecture on the game theory basics. For instance, I often have to remind the students that this is a competition where their profit depends not only on how much they order, but also on how much other students order. Because if you place a big order, I will receive a smaller ration. Now, this is neither intuitive or natural to many of the students because they used to focus on their own decisions without considering others or even completely forgot about others. So I will tell them that they must consider others' ordering decisions. However, they won't know it for sure, so information can be very valuable here. To demonstrate the value of information, I would reveal the competitive information starting in period 4. Specifically, before the students place orders in period 4, I would show them the total demand, total order, and total supply for all the retailers up to period 3, so they can get a sense of the orders placed by other teams. For example, in this game, the total demand remains stable although it varies from time to time. The total supply is the same across all periods. But if you look at the total order, it rose from initial 40 to 132 to 200 and then to 485 in period 3. At this time, I show the students the competitive information of all these orders from period 1 to period 3. And guess what? After that, they went completely crazy. And in period 6, the total order rose to 225,000. At the end, their orders become completely irrelevant to their demand. What they were doing was to guess what the others might order and how they can inflate the orders to get a good share of the supply. This led to a disastrous outcome. In period 6, the total lost sales and the total surplus inventories across all retailers are both significant, which means some retailers have tons of excess inventory while others are starved. That is, the supply chain broke down. To conclude the game and to learn the lessons, I would suggest to plot out the game trajectory, such as the total demand, total order, total supply over the periods, as well as the total lost sales and total surplus inventory. Here's an example where the figure to the left shows the total supply remains constant, the total demand remains stable, but total order skyrocketed. These are panic orders. The figure to the right shows the total lost sales and total surplus inventory. And towards the end of the game, we can see huge surplus inventory and lost sales coexisting, which indicates hoarding. Now it is the perfect time to explain the prison's dilemma, to illustrate why order inflation is inevitable. Let's look at 4 cases of telling the truth or inflating the order, for example, of 2 retailers. Here's the win-win situation, where everybody tells the truth. And here is the lose-lose situation, where everybody inflates the orders. Now, they will eventually choose the lose-lose outcome, because if one tells the truth but the other inflates the orders, the one who tells the truth will lose more. So, in the end, order inflation is inevitable, and everyone will lose, which is the prisoner's dilemma. At this point, the instructor should connect the students' game experiences to real-life businesses to show what happened in a classroom can also happen in the real world. This is the Selectron case. In year 2000, the telecom market was growing fast. The contract manufacturer Selectron had a short supply. When Selectron added up the orders from Cisco, Lucent Ericsson, and so on, the total order exceeded the rosiest forecast. So Selectron worried, but telecom giants assured Selectron that they will pay. A few months later, in April 2001, the market crashed. But it's too late to halt production from some 4,000 suppliers. Now Selectron sits on $4.7 billion of inventory, which has to be written off due to their short life cycle. Up to this point, the students have discovered a real-life disaster in supply chain management. To complete the session, I suggest to offer a solution at the end to resolve the disaster, at least partially, so the students can leave the classroom with some real learnings in their mind. Here's a good solution, the fair sharing allocation rule, which uses the past sales instead of orders to allocate supply. Here is how it works. The supplier allocates supply among customers by their percentage of the last 13 weeks of shipments. For instance, if CVS accounts for 10% of the last 13 weeks of total shipments to all customers, then the supplier reserves 10% of the supply to CVS. The advantage is that no orders, and so no games. The fair sharing allocation rule provides a clear incentive for the retailers to sell more, because they can only get more if they sell more. The rule also likely assures that the supply is sent to the markets where they are most needed. The disadvantage is that the rule is not fair, because bigger retailers will get more supplies, and they are likely to stay bigger and more competitive than the smaller ones. In addition, the rule completely eliminates the retailer's forecast of future events, and so may still result in big mismatches between demand and supply. The fair sharing rule may have other side effects, such as the high-pressure sales tactics often used by auto dealers to increase their sales so as to get more supply. In addition to high-pressure sales tactics, the auto dealers may also have accounting scandals where they may change their sales total. To recap, the hunger chain simulation is a competitive supply chain game that can be used to teach the news vendor model, shortage gaming, such as panic orders and hoarding, and the prisoner's dilemma. It provides students first-hand experiences to understand the power of the news vendor solution, to get a sense of competition where they must consider the impact of other teams' actions on their own profit, to learn that panic orders and hoarding can result in a supply chain breakdown. Finally, they learned that fair sharing is more effective, but not really fair. The hunger chain simulation works well for teaching also because it lets the student to experience a real-life supply chain disaster, where they can discover an important problem in practice. And finally, they got a solution which is effective but not perfect. So they leave the classroom with some sorts in their mind.